Hi guys, so today welcome to lecture number 6, and today's topic is going to be forces. We'll also solve some of the kinematics problems uh, for IIT JEE Advanced 2019 soon as well. But for now, we'll be talking more about forces and try to look at what kind of forces are really interesting to look at from a mechanics point of view. All right. So the first force what we are going to look at is the normal force. Okay. Normal force. So what is normal force? As the name suggests, the force acts in the direction of normal. Okay. Uh, and basically, what force is? A force is is a measure of physical interest by which uh, things tend to happen. So generally, let's say whenever you have a sentence such as somebody is forcing you to do something, for example, your parents maybe are forcing you to go for IIT JEE examinations. So, so that is also a kind of force, but it does not have a tangible way of measuring it, whether they are putting too much force or they are putting less force, whether you know. But there are other quantities in nature, other forces in nature where you can attach tangible quantities of interest to them, such as the normal force, right? And some other forces which we will be discussing today. What is normal force? Normal force is, for example, if you are standing on a weighing machine. So this is a weighing machine, and it tells you how much weight do you carry, right? So let's say I have a mass of around 65 kgs, right? The mass will remain constant, but what the weighing machine will tell you will be completely based on the normal force, right? So, so over here, the normal force will be acting. So normal force always acts whenever there is a contact of one body with respect to another. And if you would like to see how the force is how the force acts, so the force will act always towards the person who is exerting that force. So force due to man on machine or machine on earth at ground level, let's say, is going to be in upwards. So it will be acting towards him, okay, or her, or whomsoever. So that is the way the normal force acts. The the mass the the mass also exerts a force called force of acceleration due to gravity. And that force, my friends, act acts in the direction of the earth. So even if you are going at an angle, such as the plane is going at an angle, it will always act in the downward direction, okay, or towards the earth's direction, whichever direction the earth's normal points to. So the force due to gravity uh, will always have its unit vector. So unit vector of force due to gravity will be towards the normal direction of the earth. Earth or any other pulling body, for example, moon will also have its own normal direction. Mars will also have its own normal direction. And how do you get that force? Is that you multiply your mass with the acceleration due to gravity, which on flat Earth while where we are standing, for example, is around 9.8 meters per second square. We tend to use the SI units, but you can also use American units if you want, or some other British units, but in IIT JEE examination, we always care about the SI units. So mg n cap earth is your force of acceleration due to gravity. Okay, so the man will also be exerting a force mg n cap downwards, and then we'll tell you, how these forces will equate and things like that. That will be another discussion on Newton's laws of motion, not the equations of motion anymore, but the laws of motion. Okay, so we learned about the normal force. So if I am standing on the floor, on my house floor, then of the normal force which I am exerting on the floor is actually acting towards me. I don't know the magnitude yet, but the direction will be towards me. And my mass, due to my mass, there will be a force due to force of acceleration due to gravity, which will be acting downwards. Okay, and I know how much that will be. That will be my mass times acceleration due to gravity times n cap, or the Earth's normal direction, and it will be minus Earth's normal direction because it will be acting downwards. If you think about the Earth, the positive normal always acts outwards, but in this case it will be downwards. So that's why minus n cap Earth. Okay. So with that, these are the two most important forces which we would like to know about. There are also forces, for example, due to tension. So I hope you guys can catch a glimpse of it, and I am hoping that what I talked so far makes sense to you guys. If not, send me an email or leave me a comment on the comment section, and I'll go through your comments and figure out how better I can make you guys understand about these two types of forces, namely the normal force and the force of acceleration due to gravity. Um, Now we'll talk about two other types of forces. Okay, going forward, I'm taking all this off from the board. Today is going to be a short lecture as well, and probably we'll end up with an example if we find time, and we'll see about that. Okay, so then tension force which we need to worry about. So tension, the force of tension occurs, for example, you have a pulley, you have a capital mass acting on one side, small mass acting on the other side, right? So now this this rope has to be taut in order to take care of both of these masses. Again, we know that the force due to gravity exerted by mass m is going to be, so if I have plus j cap in the upward direction, then this will be minus m, capital M g j cap, because it's in the negative direction. Force of gravity due to small mass m, or force of acceleration due to gravity due to small mass m, is going to be minus mg j cap, which will be acting in this particular manner. Then because of these forces, there has to because of these forces, the rope will be very taut, and because of that tautness of the rope, there will be a tension force which will be acting away from the bodies. Okay, so tension in rope due to mass m will be acting in the upward direction, plus Tj cap, and tension in the rope due to small mass m will be also plus Tj cap. It will be away from both the body's capital mass m and small mass m. Okay. The force of acceleration due to gravity acts in the negative normal direction to Earth, but the tension and the normal force are with respect to the body. They are not with respect to Earth. You know, just making the concept clear. So these are the tension forces. Tension in rope due to capital mass m, and tension in rope due to small mass m. And after we are done with this, the only force which I can think of which will have some importance, at least in the mechanics framework, and will discover will have more and more forces which we will entertain, for example, in electrostatics and things like that. And then there will be a force of attraction when we will learn about gravitation and things like that, but I'm not going into that for now. There is another force which I find very interesting and important, and that is the force of friction. And the force of friction is a non-conservative force. So what happens is, you have a body which is in motion, uh, let's say. So it is accelerating in the positive x direction with a unit with a I cap. So the magnitude is acceleration a, and the vector direction is I cap. And you are exerting a normal force n in the upward direction, which is nj cap. You have a mass. You have a mass on the body, so basically you have force of acceleration due to gravity on this mass m. That is going to be minus mg g cap. Then if this this floor or the surface on which the body is traversing has some roughness attached to it, then there will be a frictional force, and that frictional force will have a varying magnitude. This frictional force will be equal to mu s times n in the minus I cap direction, or the direction which is opposing the movement. So if the movement is in the plus x direction, then it will be plus I cap direction, then it will be in the minus I cap direction with a magnitude of mu s n minus I cap. And I'm coming to the conditions. Mu k n minus I cap in the other case. So basically, it will be, the first is the idea of static friction. So this occurs when you are putting some force on the body and the body is not moving at all. So what is happening is, due to the roughness on the ground, the body is exerting force, a force proportional to the normal force, and it is somehow making the body not go away from its original location. And when the body is not moving, and due to frictional forces, these mechanical interlocks are trying to make sure that the body does not move from its initial position, then that force will be that force will be governed by static friction. And when the asperities are no longer able to uh, to to make the body to make the body, attached to its original position, but the body is already in motion, let's say such as here, then the body will be experiencing kinetic friction coefficient. So at that time, the proportionality coefficient in between the frictional force opposing that motion will be mu k n, and this is a kinetic frictional coefficient. And at the time when the body is not moving at all and the force is not good enough to move the body, the forward force is not good enough to move the body at all, then the definition will change to static friction in that scenario. And we will come to the definitions of this very shortly. Okay, so these are the four type of forces which I feel are very important for our further discussions, at least for the topic of free body diagrams and things like that. And basically, uh, what you are doing over here is already a subset of free body diagrams where you can where you are showing the magnitude and the directionality of the forces on this type of in this type of an abstract format. So you're already doing something which is a subset of free body diagrams, and we'll go into more details of free body diagrams pretty very shortly. Okay. So with that, we we cover the first part of the lecture where we discussed about the normal force, the force of acceleration due to gravity on a certain mass m, the tension force, and we also discussed the frictional force. All right. So with that, we would like to discuss the concept of Newton's laws of motion. So that is the next topic which we'll cover in this lecture today. And I'm hoping that you are able to take enough notes from the screen, whatever I wrote in here. If not, just pause the video and you should be able to do that. Thank you. So we'll go for Newton's laws of motion. So Newton's laws of motion. So, so in 1600s, Newton became a very famous physicist. Uh, Before him, most of the physicists are theoreticians. Newton was the first physicist who was experimentalist, and then he derived theories and basically made theories kind of fit to those experiments. So this has become kind of the law of the land in the West, where people started doing experiments first. Even now, you can see people do experiments first and then try to derive theories quite often. Um, Although there had been some changes as you know, people derived equations which govern modern physics, such as the special and general theory of relativity, where Einstein did mind experiments first, uh, derived theories. Still, it is in line with Newton's way of thinking, where he was doing experiments, but he was doing experiments which are not physical experiments. Those are mind experiments which he was doing first, trying to figure out how it will be if he would have done a real experiment, because he did not have uh, the kind of money which will be required to do these real experiments, since he was a budding physicist. And 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 and, and that is the way physics took its shape in the current century. But still, you will see a lot of Western physicists try to do experiments first and then fit it with respect to a particular theory. But it is rapidly changing, and mostly the way Eastern physics or Eastern way of thinking is to derive something based on mind experiments, and then conform and then try to do an experiment which is in line with that theory. So I think the world is coming to a common ground now because of the modern physics, and 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 atomic subparticles getting discovered. Um, I think it's for the better that we have found a common ground in terms of Western and Eastern physicists, and and that's all the philosophy and things like that. We are here to to figure out what the Newton's laws of motion are. So the Newton's laws of motion, the first law states that if you are so it's all about inertia or state of an object, okay, which could be rest or motion, right? So it's like a binary state. So what it states is that if you do not if you do not exert an external stimulus on a certain body which is either uh, which is in its inertial state, or for example the body is at a state of rest and you do not put any force to it, then it will continue to be in its rest position. And if the body is already moving, then if you do not exert an external force on that body, then it will continue to move in the similar manner. Okay, so rest will favor rest and motion will favor motion if there is no external stimulus which is going to disturb those inertial states. Okay, and by inertia I mean state of an object, whether they are at rest or in motion. It could be some other aspect as well. But for the interest of this lecture and the scope which we are trying to cover, let's just think about those two inertial states being rest and motion. Okay. The second equation of motion states that the force, whenever there is an external force which you are going to apply on a body, then that that force, so if you have an external force, that force will cause either a change in mass, or it will cause either a change in velocity. Or if you write them together, so basically what we are trying to do is it will either change the mass at a constant velocity of that body, or it will change the velocity if the mass remains constant. Okay, so if by by chain differentiation, reverse chain differentiation, you can write it as dy dt of mv, and you can write this as, so if there is a linear force, then due to application of that linear force, there is going to be a change in linear momentum. And how do you define linear momentum? You define linear momentum as mass times velocity. So if there is an external force in picture, then it is going to change the linear momentum. Then that force could be envisioned as the change in the rate of change in linear momentum of that body. So you exert a force on that body, you'll see certain change in the linear momentum of that certain body. Generally, the mass of the body for non-relativistic cases, or for example, if you're not throwing the rocket up, which is continuously losing mass due to fuel ejection, the mass will remain constant, and basically your this law. So if the mass remains constant, it can be written as m times dv over dt. From kinematics, we know that, and these are vectorial quantities. So the rate of change of velocity is going to be acceleration. So the force will become mass times acceleration. Okay, and it could be also written as F equal to dy dt mv. So if there is no force acting on the body, if there is no force acting, no external force acting on the body, then we also come to the conclusion that mv will remain constant. Okay. So there are two parts of this law. First part or three parts of this law. First part says that any force, any application of external force can be measured in times of, in terms of how much the mass is changing at constant velocity of the body on which the force has been exerted, or the change in velocity at that body's mass, constant mass, when on which the body on which the force has been exerted. By reverse chain rule, we can write that as d by dt of mv, and mv vector is nothing but your linear momentum. And basically, what we are trying to say is that if there is no external force, then d by dt of mv will become 0, and the d by dt or d by d xyz of any quantity becomes a 0 when that particular quantity is constant in that variable. So if if there is no external force which is getting applied on the body, then your momentum m times v vector is going to remain constant as a function of time. The other factor which we were trying to figure out, or which we are trying to put some more uh, thrust on, is the fact that if the change of rate of mass becomes equal to 0, for example, for most bodies which are not changing their masses as a function of time, for example, if you are not a relativistic particle, or if there is a rocket which is not ejecting fumes out of itself and its mass is not changing. So for all other massive group of mesoscopic continuum particles, dm by dt, or bodies, not particles, continuum bodies, dm by dt will become 0, and basically the force vector can be written as m times dv vector by dt, or you can write force vector, any external applied force will provide an acceleration of a vector which will have its magnitude f divided by m. Okay, so this will be the cause. If there is a cause attached, then you will see the effect in terms of the acceleration. Okay, so this cause effect philosophy is there both in Eastern and Western philosophies. So if there is a cause, then there is going to be certain effects. You measure the effects to get to the cause, or you know the cause and you can measure the effects, right? So, and this can be done both in terms of um, mind experiments or in terms of actual experiments. So, if somebody is paining you, or if somebody is giving you a lots of pain, then that is the cause, and you are going to get mad at them, and that is the effect of that cause. Because of that cause, that effect will come. It's but natural. It happens. It will happen in your life as you go forward in your future, but kind of makes it natural why you are going to have mood swings if somebody is going to pain you for no reason. So, alright, or somebody is going to act smart, are acting smart for no reason and deviating from the ground truth. Okay, so let's not go into the philosophy part of it. The other aspect is, in absence of external force, the momentum, the linear momentum, is going to remain constant. The third aspect uh, is in terms of action and reaction. So if there is there are always internal and external forces which are acting on the body, and in absence of any acceleration, if the body continues to remain in its inertial state, it continues to maintain a state of rest, or it uh, continues to enjoy a state of motion, let's say at constant velocity, then the internal forces which are originating from within the body are going to cancel out the amount of external forces you are exerting on the body. So, for example, the example which we are taking in terms of, so this is the third law of motion, and this is related to the example of friction which we were talking about. So this is your frictional force. If the asperities are good enough that they can hold the body in its original position, then it's going to be static friction, and basically your F is going to be Fs. So, so this is the internal reaction. So you are applying an external force F, and the body decides to figure out how it can resist that change in its state of inertia, and it decides to do so in terms of the frictional force, and that frictional force can be written in terms of mu s times n, where your normal force is acting in the upward direction towards the body, and mass times gravity is acting downwards. So anywho, so for this case, the F is acting in the plus x direction, and the friction acting in the minus x direction. And since the body has not left its original position, the friction force is fully cancelling the effect or acceleration which the body could have gained if the asperities would not have been there. So this is a case of action versus reaction. So every action has equal and opposite reaction if there is no change in the inertial state of the body. So this is first example. The other example is when you are measuring your weight, you're exerting a normal force of N towards yourself, and then you are also exerting a mass times gravity. And if you are not jumping on the weighing machine, not causing an upward or downward acceleration, then this normal force, or you are not doing like this, something weird, you are resting on your weighing machine, then this upward directional normal force is going to be equal and opposite to your mass times gravity. We see that it's already opposite, as the normal direction force is acting towards you, and the mass times gravity force is acting away from you towards the gravity direction. So you write this as n vector is going to be negative of minus mg vector. Now from a g vector perspective, it's already covered because g vector is already towards the negative direction, so it's equal and opposite in nature, since you are not jumping. And from here you can figure out your weight is, for example, if you have a value of 9.8, 65 kgs of weight, then I can figure out my normal force in terms of newtons, and I can get a weight value for it. The weight is a force, it's not the mass of the body. The mass of the body, no matter wherever you go, is going to remain constant. Only your weight will change as a function of space. Okay. So with that, we covered all the three Newton's laws of motion. We'll be doing and I'm thinking about it. I would say that I'm not going to do any examples, numerical examples today, as I'm figuring out it might become a very long lecture, so I'm going to avoid that. And I'm hoping that if you have any doubts understanding these three laws of motion or the four forces which I talked to you about before, then you can shoot me an email or give me a comment in the comment section, and we'll go from there. Next lecture, which could be possibly today, could be possibly tomorrow or after I come back from somewhere I'm going, uh, is going to be possibly a week from now, but that will cover a lot of examples. Also, I'm interested in solving some of the kinematics problems from IIT JEE Advanced 2019 for you. So that I'll probably cover and during the next weekend. All right, have a great night, and hope I have been useful in communicating some of the concepts to you, probably in a manner which makes more sense for your JEE examinations. And with that, I take your leave and hope you have a great night. and great rest of the rest of the weekend if you're in US, and if you're in India, then the classes are going to be there tomorrow as well. Thank you, and have fun. Bye.